Our last focus on forces in motion here is gravity. We've got a couple essential questions that we're looking at. First of all, what is the universal law of gravitation? And then also, what are the two variables that affect gravitational force? If they change, what's the relationship then that we see with the force of gravity? Do we notice that the force of gravity will increase or decrease because of those two variables? So look for those as we discuss today. Now here's our friend Sir Isaac Newton, and he's telling us that gravity is the attractive force between two objects. Okay, so gravity attracts objects together. We know the Earth, of course, has a big gravitational force for us and everything here on Earth. But we also have an attractive force to the Earth. It's just much smaller, so we don't think about that one as much. Now it's important to consider that every object that has mass has a gravitational force. So no matter what the object is, it has some level of gravity to it. So even air has mass. Air, we know, is made up of molecules, and therefore they have a very small mass. It's present. So air even has a gravitational force, keeping it pulled to the Earth. Now the force of gravity between any two objects is going to be affected by two characteristics, both by mass and by distance. Okay, mass and distance, as those objects or those factors change, we see a change in the gravitational force, either an increase or decrease, depending on how the mass and distance has changed. Now the exact gravitational force of an object can be calculated using this formula. The law of gravitation says if I have the gravitational constant, which is here 6.67 times 10 to the negative 11th, that's for Earth. Right, if I use that gravitational constant, multiply that by the mass of the two objects that I'm calculating and the distance between those objects, I can use this formula to figure out the gravitational force between the two. Now as we run the numbers, we notice there is a steady relationship between two factors and the force of gravity. And remember, those forces are mass and distance. We notice that as the distance between two objects increases, the force of gravity is going to decrease. So we know that all galaxies are moving further and further away from stars, from the Milky Way. So as those galaxies get further and further away, their gravitational force with each other is dropping. It is important to note that no matter how far apart those objects become, the force of gravity will always be present. It will never go away. In terms of the relationship between mass and gravitational force, we know that as we increase the mass of an object, the gravitational attraction also increases. So the more massive the object, the more of a gravitational force. And that makes sense because we notice that bigger objects, more massive objects, are harder to move because the force of gravity is pulling them down at a stronger rate to Earth. So on the right hand side here, it does ask you to label which pair between the two here, label which pair would have more or less gravitational force. So we know mass, if mass increases, gravity increases, so I'd label this one here as more, this guy here is less, and also state the relationship between the variable and gravity. So the variable here is obviously mass. How does mass affect gravity? Put it into your own words next to that picture there. And make sure you go back and do the same thing for the distance picture. Couple practice problems here before we get to our summary. Two stars of equal mass are 10 million kilometers apart. What happens to their force of gravity if the stars move twice as far apart? So we have two stars with equal mass are 10 million kilometers apart, and then what will happen to the gravitational force if their distance doubles? So now I'm 20 kilometers apart. Okay, we know that the gravitational force will decrease. The further apart the objects are, the lower the gravitational force. Again, thinking about the stars, if one of the stars has an increase in mass, so I have the two original stars, but then the second star took in mass from a neighboring star, changing its mass will then how affect the gravitational force? Well, if the mass increases, I know the gravity then will also increase. Take a quick check back through the notes, make sure you got everything, have anything written on the right hand side that you need, and then use the last little bit of time here to make sure that you finish those section check questions along with the summary questions for our next class.